Welcome to part 2 of 8.5. You'll notice once again over here we have 3 variables and 3 equations, and each of these equations has all 3 variables represented. So this is going to be more like the first example. I'm going to label these 1, 2, and 3. So we have 3 different equations we're looking at over here. So it is advantageous to take a couple minutes just to determine what the easiest thing going to be to eliminate is. Now, if we look at the x's, 2x, and 3x, not too bad. Y's, a y, a 6y, and a negative 2y, not too bad. Z's, a z, a 3z, and a 2z. Those aren't too bad, so it doesn't really matter. I'm just going to eliminate the z's here. Now, I'm going to use first the second and the first and the third equations to first eliminate the z's. So I'm going to write the first equation down. We have our 2x plus y plus 2z equals 3. So in order to eliminate the z's, I'm going to have to multiply this third equation here by negative 2. So multiplying in here by negative 2, we get negative 6x, a positive 4y, a negative 2z, and then negative 2 times 0 is 0. So we're multiplying that negative 2 by each of the terms here. Add these up, negative 4x plus 5y, the z's cancel, equals 3. So now I'm going to put that over to the side. Or negative 4x plus 5y equals 3. So we've used the first and the third to get rid of the z's. Now I'm going to use the second and the third to get rid of the z's. In order to do that, I'm going to multiply the third equation by negative 3. So I copy that second equation down. X plus 6y plus 3z equals 4. Now multiplying by our negative 3 here. Negative 9x plus 6y minus 3z equals 0. So once again, I multiplied everything in there by negative 3 to get rid of these z's. And then we add these up. So we have negative 8x plus 12y. Our z's cancel. That equals 4. So I'll put that over in the repository. Negative 8x plus 12y equals 4. Now, the whole idea is to get down to this point where we have 2 equations and 2 unknowns, and this is going to allow us to use old techniques to solve for x and y. So we're going to use these 2 equations to solve for x and y. Then once we have those, we can come back here and use one of the original equations to solve for z. So we're looking once again for an ordered triple, some x, y, z combination. Okay, so looking back at these 2 equations over here, it looks like the x's are going to be pretty easy to eliminate, so I multiply this first row by negative 2. That gives me 8x, so negative 2 in here, it's going to be minus 10y, negative 2 in here equals negative 6. Add these up, those cancel. 2y equals negative 2, divide by 2, we get y equals negative 1. So negative 1 is our y value. Now we can plug this back into anything to get our x. I'll just plug it into this equation right here. So negative 8x plus 12 times negative 1 equals 4. So negative 8x minus 12 equals 4. Add 12. So we get negative 8x equals 16 divided by negative 8. We get x equals negative 2. So, x is negative 2, y is negative 1. Now, in order to get our z, we need to plug x and y, or at least some of these, back into something that has a z in the equation. So, we've been having really good luck with this third equation, so I guess I'll just plug it in here. So we have our 3 times our negative 2, that's our x, minus 2 times negative 1, that's our y, plus z equals 0. So kind of expanding this out, we have negative 6 plus 2 plus z equals 0, or negative 4 plus z equals 0. And then finally solving this for z, we're going to add 4 to both sides, and we get z equals 4. So the solution here, negative 2, negative 1, 4. And we can always plug these back into these equations to make sure they give us true statements to check our solution. So that's kind of the procedure here. Now we go down to this last one, and this one is much like the last one where all 3 equations have all 3 of the variables represented in it. So, it might be advantageous just to take a look and think about what, and I'll number these again. We have 1, we have 2, and we have 3. What the easiest variable to get rid of is. Now, the x is 2x, and 3x, not too bad. The y is negative 3y and positive 3y. Well, that's screaming get rid of the y's, because that'll be a fairly easy step. So I think we're going to go with that. The z's, not too bad, but I think the y's are easier. So we're going to eliminate the y's. So using the first and second, 2x minus 3y plus z equals 5, and x plus 3y plus 8z equals 22. Adding these up, we get 3x, the y's cancel, plus 9z equals, now if we have 5 and 22, I guess that's 27. So I'm going to put that over to the side. 3x plus 9z equals 27. Okay, so we use the first and the second. Now we need to either use the first and the third or the second and the third. And I recommend using the second and the third because they're of opposite signs. So using that second and the third to get rid of the y's once again, and we're getting rid of the y's because we already have an equation over here that has no y's. So I guess we just copy down the second one, x plus 3y plus 8z equals 22. And then if we multiply this third equation here by just a 3, we're going to get that negative 3y. That'll be good. So I'm multiplying all these by 3. 9x minus 3y plus 6z equals 3 times 12, 36. So once again, I'm multiplying all of the terms in this third equation by 3 to get our 9x, our negative 3y, our 6z, and our 36 to eliminate the y's because we already have an equation over here with no y's. So adding these up, we get 10x. Y's go away. Then 8, and that's going to be 14z. And this is going to equal 22, and that's 58, I'm thinking. So let's put it over here. So over here, notice we have this. So we have 10x plus 14z equals 58. Okay. So here, the numbers are a little bit big. We still need to get rid of some things over here. Because 3 and 10, I'm fairly good at multiplying by those things. I'm going to get rid of the x's, but you could get rid of the z's. So in order to get rid of the x's, I'm going to multiply the first equation by negative 10. Because if we think about the lowest common denominator, least common multiple between 3 and 10, it's 30. So when I distribute that in here, we have negative 30x minus 90z equals negative 270. So distribute the negative 10 on all these, which means now I need to multiply the second equation here by 3. So distributing in there, we get 30x plus 14 times 3 is 42. So 42z, and then 3 times 58 is 174. So adding these things up, the x's cancel. If we have negative 90 plus 42, this is going to give us negative 48z, and this is going to equal negative 270 plus 174 is negative 96. Divide by our negative 48. And when we divide that by negative 48, you'll be pleasantly surprised to know that the z equals 2. Okay, so we know we have this ordered triple, some x, y, z combination. Our z is 2. In order to solve for x, we plug this back in. I'm going to plug it back into this equation here. So we have 3x plus 9 times 2 equals 27. So, here, so we have 3x plus 18 equals 27. Subtract some 18s. So we get 3x equals 9 divided by 3. X equals 3. So, once again, we've used the two red equations here to get the x and the z. The last thing we need to do is get the y, and we need to go back to these original equations right here to get the y. Now I'm going to use the third one. It doesn't really matter which one you use, so I'm going to plug these values into that third one. So we have 3 times our x, which is 3, minus y, which is what we're trying to solve for, plus 2 times our z, which is 2, and this is going to equal 12. So, kind of moving through this now, we got 9 minus y plus 4 equals 12. So negative y plus 13 equals 12. Subtract some 13s. We get negative y equals negative 1. Divide by negative 1. You get y equals positive 1. So the solution to this, 3, 1, 2. I implore you, while you're doing these in the homework and such, be really careful. Stay organized, stay systematic, and you're going to avoid having some sign issues and getting into some really bad scenarios. So, good luck, and we'll see you next time.